Happy New Year! Now we will discuss the X-ray production and X-ray machine. Before we discuss how the X-rays are produced, we should know some definitions about radiology. Radiation means transmission of the energy through space or the substance in the form of waves or particles. In the form of the waves or the particles means that it may occur in two forms, may be particulate radiation or electromagnetic radiation. Particulate radiation means a tiny particle possesses a mass and traveling in a straight line at high speed. The particulate radiation mainly and primarily produced by disintegration of unstable atoms. Large atoms that has unequal distributions of protons and neutrons are unstable. They tend to disintegrate or break up, forming or releasing some particles and rays. Particles like alpha particles, like beta particles, and rays like gamma rays. So, particulate radiation have four types: alpha particles, beta particles, protons and neutrons are also considered as particulate radiation as they are moving at high speeds and passes. Electromagnetic radiation means movement of the energy through space as a combination of electric and magnetic field. Electromagnetic radiation means electric and magnetic. Electric field and magnetic field perpendicular to each other in a wave like. Some examples of the electromagnetic radiation like X-rays, gamma rays, microwaves, visible light, TV waves, radio waves, all these are examples of electromagnetic. About X-ray characteristics, firstly we should know that the appearance of the X-ray, they are not visible. It's invisible. It can't be detected by any sense. It also has high energy and shorter wavelengths waves. No mass, no charge. It travels at speed of light, travel in a straight line. It can't be focused. It travel in a straight line but can't be focused. They can be distracted and scattering, so it can't be focused. It also can penetrate different types of substance, maybe gaseous, liquid, or solids, and some of our parts of the X-rays may be absorbed by the substance. It can cause fluorescence or glowing of the fluorescent plates, and it has effect on the living tissue and the photographic film. The X-rays first discovered by a German physicist called William Roentgen when using a Crookes tube, which is a glass tube with two electrodes, negative electrode and positive electrode, and then operated by a battery. He discovered that there is a fluorescence and the glowing of the fluorescence plate placed in the darkened room, and he said that some rays emerging from this tube, which is called cathode tube, and cause glowing of the fluorescence. And he put his wife's hand on the fluorescent plates for about 15 minutes to detect if any rays emerging from the tube, and this is the first radiographic, first X-ray radiograph or photograph of the Roentgen wife Bertha hand, and called it X-rays. X-ray machine composed of three visible components. First is the control panel. This is the control. First is the control panel, as we said before, on and off switch and indicator light, exposure pattern with indicator light, and the exposure factors can be controlled from the control panel. The extension arm, or we also said that extends from the panel to the tube head, allowing for positioning of the tube. Tube head. Tube head is a tightly sealed metal filled with oil. The oil prevent overheating. The oil absorbs the heat, so prevent overheating of the X-ray machine. the metal housing protecting the high voltage components, the high voltage component like transformers and like X-ray tube head containing the X-ray tube is a primary X-ray generating system. The tube head is sealed from this area. Tube head contain at its end what's called aluminum disc filtering out of the longer wavelength X-ray. We only need shorter wavelength X-rays with higher energy. So the filter in the aluminum disc filtering the longer wavelengths and lower energy X-ray. After that, there is what's called lead collimator. We will see a diagram for all of these after. A lead collimator, which is restricting the size of the X-ray beam, and after that the position indicating device which shapes the X-ray beam. This is the position indicating device. The position first is the control panel, as we said before, on and off switch and indicator light, exposure pattern with indicator light, and the exposure factors can be controlled from the control panel. The extension arm, or we also said that extends from the panel to the tube head, allowing for positioning of the tube. Also, we said that the tube head containing transformers. The X-rays first discovered by a German physicist called William Roentgen when using a Crookes tube, which is a glass tube with two electrodes, negative electrode and positive electrode, and then operated by a battery. He discovered that there is a fluorescence and the glowing of the fluorescence plate placed in the darkened room, and he said that some rays emerging from this tube, which is called cathode tube, and cause glowing of the fluorescence. And this is X-ray tube, glass vacuum tube, leaded glass vacuum tube, and cathode and anode, and from air, as we said before. First, the tube is composed of two electrodes, cathode and anode. Cathode is consisting from what's called tungsten. Why we use the tungsten? Tungsten is a thin wire, but it's very strong. It has a high melting point, so it can't be melted at high temperature, and it has less tendency to vaporize, and it has long life expectancy. So the tungsten is the best choice for the cathode filament. The focusing cup, which is the second part of the cathode, is made of molybdenum, and its function is focusing of the electrons. After the electrons are produced at the filament, it needs focusing to be directed towards the anode. So the focusing cup, or the molybdenum cup, focusing the electron into a narrow beam towards the anode, directed at a small area on the anode called the focal spot. The focal spot where the kinetic energy of the electrons are transmitted into or converted into X-ray photons. So the focusing cup, its function is focusing of the electron into narrow beam directed toward. The second compartment of the X-ray tube is the stationary anode, or the anode, which is consisting of a target embedded in a cover stem. The target is made of tungsten. Why tungsten? As we said before, it has a high melting point withstanding high temperature, but also it has a high atomic number. High atomic numbers means more electrons are stimulated, more electrons are excitants, and as the electrons are increased, the number of the photons of the X-rays increased also. And it has high thermal conductivity. When it has high thermal conductivity means it can dissipate the heat through the copper stem connected to it, so it prevent overheating of the tungsten target. The anode, its main function is converting the kinetic energy of the electrons coming from the cathode into X-ray photon. This is the X-ray tube again, with the anode and tungsten target, and the copper stem. The copper precipitate the heat, as we said before. When the electrons are striking the tungsten target, all its kinetic energy is converted into X-ray photons and heat. 99% of the electrons kinetic energy is converted into heat, so it can be dissipated by the copper stem, which is a cathode. Again, this is the copper stem, and this is the tungsten target, and this is the how the X-rays are produced. We have a circle. First, when the machine is turned on, the electrical current entering from the control panel toward the X-ray tube head. From the tube head, there is the transformers. As we said before, we have a step up and step down transformers. In this case, the step down transformer will be operated, and it will reduce the voltage of the X-ray incoming electricity from 110 or 220 volt to about only 3 and 5 volts. 3 and 5 volts are enough to heat the tungsten filament of the cathode. When the tungsten filament is heated, it releases electrons, and more release of the electrons, which forming an electron cloud around the filament. This electron cloud and this stimulation of the electrons and formation of the electron cloud called thermionic emission. The electron stay in the electron cloud until the high voltage circuit is activated. How the high voltage circuit is activated? By pushing the exposure button present in the control panel. When the exposure button is pushed, the high voltage circuit is activated. This means the step up transformer is present, is operated, and it increases the voltage of the incoming electricity to a high voltage. This is the difference between voltage. The difference in the voltage between cathode and anode make the electrons accelerated, stimulated to strike and accelerated across the tube to the tungsten target through the molybdenum cup, which focusing the electrons towards the tungsten target. When the electron is striking the tungsten target, their energy of motion, which is kinetic energy, is all converted to X-ray energy and heat. Only 1% of the energy is converted to X-rays, and 99% is lost as heat. The heat must be dissipated, as overheating may cause burnout, and we don't need that. 99% of the heat is dissipated through the copper stem and the insulating oil present in the tube head. Then the X-rays produced are emitted in all directions, but because the X-ray tube are made mainly from a leaded glass housing, it prevents X-ray from escaping in all directions, only escaping from the window. The window is made of unleaded glass. All the X-ray tube is made from the leaded glass to prevent escape of the X-rays. but the window is made only from unleaded glass to allow the X-ray to emerge from it and traveling to the tube head seal and then the aluminum disc, which filtering out the longer wavelength X-rays. And then the size of the beam is restricted by using the lead collimator, and then the beam is shaped by the position indicating device toward the tissue. This is how the X-rays are presented at its end. X-ray machine, which consists of aluminum disc, first is filtering out of the longer which can X-ray on and off switch expose shorter wavelength X-rays are emerged from the machine. So the filter key for aluminum disc exposure filtering the longer wavelengths and lower energy X-ray. After that, there is what's called this is the control panel, and it's connected to a diagram extension arm after lead collimator, which is restricting the size of the X-ray beam and positioning the position in the tube device, which shapes the tube X-ray tube head is the metal housing which containing the X-ray generating system. you.